All right, for today. First off, this little drawing reminds me of what I told you yesterday about if this had been an inverse trig question, we would have had it limited between, for sine, it would have been in here. Do you get there's only one answer in there? If I limit it to inside the green little circle there? If this was not inverse trig, which it isn't, then it would usually be limited to between 0 and 2 pi. Do you get, if I go from 0 to 2 pi, that's going to be like in here. Do you get that I just missed a third solution by cutting it off right there? That would have been, if I had said all solutions, then I'd be saying, okay, take these solutions and add how much to them? How much does it take to get over to there? You add 2 pi. And if you wanted to add more than 2 pi, if you wanted to add 4 pi or 6 pi or 8 pi, you could. So we say plus 2 pi k. So that's why we add that in, is to show the extra solutions are going to be moved over 2 pi. Would this bottom one also get moved over? Yeah, and also gets moved over 2 pi. Can't see where that would be, but there'd be another solution right there. Okay, so you take both solutions and you say plus 2 pi k. But what if it's got a different period? Well, then it won't be plus 2 pi anymore. It might be like plus 2 pi over 3 times k. So the period, I know, it's not always a period of 2 pi. Does this one have a period of 2 pi? Yeah, because I can see it starts at 0 and it completes a full cycle by right there, which was 2 pi. So yeah, this one has a period of 2 pi. So I would add plus 2 pi k. All right, so that's a good review of the stuff we did the other day. So what are we doing now? Well, it's one of my favorite things because it's kind of complicated, but not tragically. But it's one of those where you can start with a problem and like go down a whole page before you get to the end, and you'll be able to do it because it's like a little chain of first you got to do this, then you got to do that, then you got to do this other thing, and you'll know each step. I really think you will. All right. So before we start this, I want to remind you that the identity sheet is something that is going to be allowed on this test, and it's allowed right now. So would you please find your identity sheet? It is not in the normal folder like for the day, but you should have one by now somewhere. Pro tip, if I were you, I would take a screenshot of it. Then you can always find it in your pictures. Otherwise, get the identity sheet up. Because when I say, okay, so what's cosine of 2 theta? You got to be able to find it. And you'll have a whole bunch of choices. Okay. Then, let's get to it. Well, this is actually the beginning of your assignment. So where was the lesson, Mr. Surver? Well, I'm going to throw in some stuff on the side, but we're going to actually just jump in and act like, because somebody last hour was able to do it without any help, and I bet there's somebody in here that can do the same thing. This looks like, holy crap, I've never seen anything like that. How am I going to solve that? Yet somebody pulled it off last hour. I bet as a group, we are definitely smart enough to do this without Mr. Surver telling us how. I will just try to direct, like, who should talk next to try to, like, keep us moving. Who has a theory on what we could do to start? Yes?
Change the cosine 2x to 2 cosine squared x minus 1.
You are absolutely right. Notice I didn't tell her what to do, but I did verify, yep, you did it right. She swapped it out for, could you say that again?
2 cosine squared x minus 1.
Now, there were 3 choices. How did you know to pick that one? Was it just a guess, or was it a gut feeling, or? Oh, you wanted the cosine to be the only function in it. That makes some sense. Just keep the same function throughout the problem. I like it. Okay. Again, trying not to tell you how to solve this at all. Willing to take ideas from the crowd. Who's got a thought? What are you thinking, sir?
Take the one and add one on each side.
All right. Yes, we can do that. Do you have an idea of why you want to do that?
Eventually, we could take the cosine over to the other side.
Okay, so then if we subtract cosine from both sides, then the cosine is going to go to the other side. And you're not wrong. I'm gonna rewrite it from here. 2 cosine squared x minus cosine x is equal to, we added 1 to both sides, so equals 1. This is not an easy thing to do as a group because there's a lot of ways you could go. Imagine for a second if I said, okay, you guys design a car for me. You get some people be like, well, I think it should be like a sports car. Other people be like, I think it should be an SUV. I think it should be like a giant truck. I think it should be a Cybertruck. Anyway, my point, there's a lot of ways you can go with this. So there's not necessarily a right answer, unless at the end, if you can solve it. What is the point? What do we want? When it's done, what does it look like? Is it the number like 7? I mean, what is this thing that we get at the end? It's an angle, because aren't these spots angles? So in the end, don't we want an angle? All right. So now, Young Hai, you had your hand up, and I was rambling.
I just factored out cosine x from.
All right. So you figured that there was an x in both, or a cosine x in both of them?
Yeah.
All right. Now, before we get too far into the weeds, you're warm, but something's going to go wrong terribly. So, from where I am right now in this problem, you need to do something else. That wouldn't help. Sorry, I'm guiding a little bit, but I'm just saying nope. So, what could you do? When you hit on it, I'll tell you you're right. We're at the black line there. Yes? So don't overthink it. Subtract 1 from both sides. One of our earlier ideas actually was just before its time. All right, so now we have 2 cosine squared minus cosine x minus 1. And why did you want it equal to 0? That was your gut. Why? Factoring. I just had a chill run down my back. Yes, you can factor it. I'm so proud. I'm taking a different approach than I did last hour. Last hour, which is kids that are just about, same level of intelligence as you. And I just asked them to solve it, and nobody came up with it. And I said, we have a lot of really smart kids in the room, and nobody can figure it out. Does anybody know what we should try? Anyway, my point, once again, here we are in a really hard problem. And you guys did figure it out. I had a couple people that were kind of leading the way. But the point is, if you're stuck on a really hard pre-calc problem, the answer is factor it. Again, this has been like I don't know how many times. So we should start a tally mark on the wall every time that it was factoring and nobody could think of it. But this time somebody did. Awesome. Maybe it'll happen to you on the test and you'll be like, oh, it's factoring. The thing he says is usually the answer. All right, so then how do you factor it? Who's got it? What do you think? All right, and really if you wanted to just take baby steps on that, you could have realized it has to be a cosine and a cosine. And then to make 2 cosine squared, one of them would have to have a 2. And then you could think, well, how do I make a negative 1 happen at the end? Has to be a positive 1 and a negative 1. Yes? Okay, and you're right that I just have to check this now. So I'm going to check it, and here we go. Outside and inside make the middle. And I think I just heard that my outside and inside will make positive cosine x. Whenever you get the opposite of what you wanted, you switch to the opposite signs. So I'd like to think of it as instead of changing the numbers around, I'm just going to change the signs around. It'll be the same thing as you just said. Just instead of a plus there and a minus there, we'll put a plus here and a minus here. See what I mean? So if you ever get the opposite of what you wanted, change to the opposite signs. Okay, yay, it's actually factored properly. But there's still going to be a good chunk of kids that are like, so I don't know what to do. So let's keep going. Who's got a suggestion? I mean, in the end, I want angles, and I don't have angles yet. Yes?
I think you could find a solution to both of those problems.
What? This is a problem, but it doesn't have an answer. What do you mean? Playing
So
devil's
you set
advocate.
each side equal to 0.
2 cosine x plus 1 equals 0.
And then you solve the cosine of x.
And then you solve. And then the other side?
Same thing.
Cosine x minus 1 equals 0. Yes, you got 2 equations. Joel Asterhus, tell me how to solve the blue one.
Subtract 1, so you get 2 cosine x equals 1 and divide by 2.
It's equal to negative 1, and then I divide by 2. And I get cosine of x is equal to negative 1/2. Again, somebody right there is not going to know what to do. But I think you might.
You need to do the cosine inverse to get x.
All right. And absolutely would work. But you'd be forced to put in on your calculator inverse cosine of negative 1/2. And you could do that, but you'd be dropping an answer because the inverse cosine problems only give you one answer. Can you tell from my context that maybe we should take a different tack? What do you think? Any thoughts?
Well, since we're doing the circle thing, we're going to want to make the adjacent side -1, so we're probably going to want to do S and T.
Okay, so adjacent and hypotenuse. And, okay, so you're saying cross off these?
Yes.
All right. So those are the places where cosine was positive. I agree. We must be in here. And as you said, the adjacent is -1. And then the hypotenuse is 2. And this must be square root of 3. And then this would be a 60. And why isn't the answer 60?
Radians.
So what radians?
It's going to be pi over 3.
Okay. And then factor in the fact that it goes from here to here.
So it's going to be 2 pi over 3 and
2 pi over 3, and this is 3 pi over 3, but that's not right. Right? There's no answer on a quadrantial. And then there's this last one is here. Don't have to reinvent the wheel. We can just jump right to 4 pi over 3 like you said. There's my 2 answers. 2 pi over 3, 4 pi over 3. Now pause for a moment and say, holy smokes, look at how much we just did. We had to know that we could swap something for a trig identity. Then we had to know to set it equal to 0. Then we had to know how to factor with trig. Do you get when kids that come into this class and can't factor normal algebra? They're in for trouble because right in the middle of this problem and you can't factor, you're done. That's why I really bang on that top 20 to make sure you've got all those little things, not just factoring. Yeah, that's the biggest one. But there's a lot of little things in that top 20. And if you're like, well, I knew factoring, was there something else you didn't know? And have you got it down now? Because if your top 20 is still like a 14, that means there's 6 things that kick your butt. Fix it, because they're all going to come up this year or next year at a minimum. All right, so back to this. You've got it factored, and then you get the answers. And then why, if I wrote these 2 answers, would I get it marked wrong? Because I haven't even finished yet. There's more answers. This is an intense question. If I've gone that much work, that many steps, and I got 2 answers and I'm still going to get it wrong, because I haven't finished. Cosine of x has to equal 1. Circle, and this one's kind of cool because it's a quadrantal. Everybody think about what you think the answer is, because it'll tell me whether or not you know quadrantals. This one's going to be Aaron D. Aaron, do you know how to do this? Do you want some help?
The cosine equals x? Right?
Yeah, cosine x equals 1?
Yeah. So it's the right one.
You are correct. Now, choose wisely, and I'm going to show you something. You might be like, choose between what? Between 0 and 2 pi. You got to pick. And here's the directions all the way back to the top. What do you think? Should you pick 0 or should you pick 2 pi? You even have to know, yep, it's 0 because you have to know these symbols apart. That's saying 0 is included. That's saying 2 pi is not included. You see what I'm saying? So many little things to know. And people wonder why Precalc is harder than higher algebra. Why was this class at one point the most dropped class at Minnetonka High School? This is why. Okay? And I'm not saying that some of you aren't wishing you had dropped at this moment, because I know it's hard, but it's kind of cool, isn't it? You take something that was really complicated, you make it a little better, a little bit better, a little better, and then all of a sudden it turns into last chapter, circle trig, and then you get further and further, and then you got to know things like, oh, but there's no solution on certain kinds. You'll see that later. So you just have to know so much math. And how many steps have we done? And we're not even done with one problem. Holy crap. So that's why trig is hard. Because not because each little step is that hard. Each little step isn't that hard. There's a lot of steps. All right, so finish it off. Final answer. I think you said 0, didn't you? Aaron, was that you that said 0?
Yeah, I said 0.
Okay, you are correct. So the final 3 answers are 0, 2 pi over 3, and 4 pi over 3. All right. Would you suspect that this problem might be similar? All right. It is. I'm going to just give you the first step of it, and then I think you should finish it from there. Now, do you notice that there's a cosine in it and a sine in it? That is, it's ideal world, you get it down to just one function. Mr. Colgan, can you figure out how we can get this down to just one function instead of 2? Okay, I'm going to give you a hint. One of these things is on the sheet. Look on the sheet. There's 3 choices. Choose wisely. So we're going to take this 3 here and times it by 1 minus 2 sine squared, and then it'll equal sine x plus 2. There's the first step. Now, it's pretty much like last problem, except without me walking you through all of it. Okay. Do you get that if, let's say that you had a cheetah out in the plains, and the cheetah has little baby cheetahs, and the little baby cheetahs are going to need to learn how to hunt. Do you get if mommy just keeps feeding them all the way into adulthood and just keeps on tearing up the food for them, and they're never going to learn how to hunt? If I just do this problem for you, you'll never know to do it yourself, right? Now, do you think that the little baby cheetahs learn how to hunt without any help? No, they watch the mama. I'm the mama cheetah. All right. Now, I'm going to weirdly not give you this answer. Why? Because this is your homework. And we have a key. So you can know if you did it right by looking at the key. Okay? I'd like you to give you one more tip on a problem that is similar to this. Let's go to the next page. I know you weren't done with the other one, but trust me, you'd like to get some more help from me before we wrap up. So everybody turn to the yellow page. And one of these things is not like the others. Number 33. Why? Yes, sir. Yes, the first one we've ever had with tangent in it. Doesn't have to have tangent in it. Chloe, any thoughts from the hint I just gave? Doesn't have to have tangent in it.
Yeah, you could change it to sinus and cosine.
And what other substitution might you consider? Within the same problem. I don't mean like, yeah, that was a good choice. You're done. It's sine over cosine. But what about the other part of the problem? McLaren, I think you can do it.
Oh, sorry, I didn't know you were saying.
Yep, still you.
Could sine 2x be 2 sine x cosine?
Did you have that memorized?
No, I'm looking at the sheet.
All right, thanks for being honest. It would have been even more impressive if you'd have pulled that out of your brain. Does anybody have that memorized? Nobody's willing to say it, but I bet there's a few people that do. That's one that you should memorize. Know why? About this time next year, there'll be a big test you'll all be taking in math. Ever heard of the AP Calc test? 1 year from now, you'll wish you had that memorized because it'll probably come up. Sine of 2x will be in there, and you'll be like, dang it, Surver told me to memorize that, and I forgot to memorize it. All right. Because they won't give you a sheet. The AP test doesn't give you a sheet with trig on it. Okay, so Mr. Surver, you always said to get it down to one function. Well, you can't always get it down to just one function. So I think I should help you a little more here because I think a lot of people would give up on this one. Just tell me the next step. Myung-Hai, I think you'll know.
Maybe you can multiply both sides by cosine x over sine x.
Cosine over sine. Interesting. I'm trying to piece together if that could work. The problem is that then you're yes, the right side gets super easy. It's just 1. But the left side has a cosine squared in it, which is going to still be a pain in the butt to solve. So, okay, you know what? I'm going to go with it. I think it'll still work. Not what I expected you to say, but I think it'll still work. If you guys want to wait and watch me for a minute, see if it works, that's cool. All right. So now I have 2 sine x cosine squared x equals sine x. Okay. It feels a little better because it doesn't have a fraction anymore. Now, I think you actually said to multiply by cosine over sine, but I just did it in 2 steps. I'm now going to divide both sides by sine x. And the problem, okay, I now see why this is going to be a bad thing. The problem is, do you get your signs are going to cancel, which seems like a really good thing. The problem is, you've just lost a solution. Sine x could have made this, the number you'd stick in for sine could have solved it. And by doing it this way, by dividing both sides by a variable effectively, you are causing yourself to lose a solution. So I'm sorry if you guys did follow me on that one. I'm backing it back out because that's why it's going to make sine cancel, and that's bad. You don't want things like functions to cancel. Why don't you want functions to cancel? Because when they cancel, they take their answers with them. And you might think something that had 3 answers is better if it only has 1 answer, but if there's really supposed to be 3 answers and you only know 1 of them because you canceled one of the functions, that won't be good. Okay, so bottom line, thank you for trying, but that wasn't it. It's a good guess. Who knows what we should do from this moment right here where we got 2 sine x cosine x and sine x over cosine x. We did it on the last problem. What did we do on the last problem that we haven't done on this problem yet? Yes? Nope. Good guess. Thank you for thinking of that. Yes. You're all a whole bunch of really smart kids and there's going to be factoring involved. But as you said, it can't just factor right now. Maybe we should find some way that it can factor. Oh, love it. Somebody remembered back to the beginning of the hour. So what could you do to somehow make this thing factor? Nope. Nope. Okay. I'm gonna show you something that is important. Is it time to factor? Why not? Oh, you want to get it equal to 0 first and then factor? Is that just you being picky? No, it just won't work until you get them all together and then you can factor it. Okay, so there's your hint. So what do you think we should do next? Subtract it on both sides. And I will have 2 sine x cosine x minus sine x over cosine x is equal to 0, the magic words. Did you know that every quadratic you've ever solved, they should be set equal to 0? And these are just quadratics that happen to have trig in them. You always set them equal to 0. Okay, so now I know it's still ugly. Think of it as a challenge. And it's a doable challenge. This is not an impossible challenge, like run all the way around the world by next week. Yes. Yes. They both have a sign in them. I saw the signs, and it opened up my eyes. And yes, I'm quoting a pop song. Would you agree I have made it into a multiply problem? Then if this part is 0, do you get the whole thing will be 0? If the red part is 0. If the black part here is 0, do you get the whole thing will be equal to 0? As soon as you got it factored and equal to 0, then you're done. I mean, it's always going to come out the same from there. Sine x equals 0, and all of this, which I know you're like, what the heck's going to happen? But I'll show you. 2 cosine x minus 1 over cosine x has got to equal 0. Now there's the B team problem, as in, if you're barely making it in this class, you can take that one. There's the A team problem. I want to join the B team. Okay, I get it. Step up. Join me in the A team. No, don't wanna. And I get it. Some of you would actually say the same thing about the sports teams. Like, that's just too competitive. Don't like it. Want to have fun with it. But some of you aren't going to have fun unless you're trying the challenging one. Stretch yourself. How am I going to make that equal 0? I should probably make a list of rules. No, that sounds terrible. Strategies that you should try. And one of them is if you can factor it, you should. And you've seen it like 65 times just today. Okay? So this is another one of my rules. Not rules, strategies. I got to make it a positive thing, right? You did it before. Don't be afraid to do it again. You did it before. Don't be afraid to do it again. Earlier today, you had a really good idea. It's time to pull it back out again. You just did it before it was time. It's like inventing an electric car 20 years ago. They actually had them. The batteries are so weak. You go like a quarter of a mile. Yay!
Add 1 over cosine x.
What? That's a 1 over cosine x, yes? Yes? You can multiply it by cosine. Remember how you cleared the fraction before? How come you can't be as smart as earlier you? That's not nice. I'm just teasing. All right. So 0 times anything is still 0. That's cool. And the cosine times the cosine makes it 1. And this cosine becomes cosine squared. 2 cosine squared. Can you solve that? Yes?
Can you divide it by 2 and then it's equal to sine squared?
Ooh, yes, but okay, if you turn that into, I get what you're thinking. You're thinking swap it back for something on the sheet, but then you won't be able to solve it. Like it'll be cosine of 2 theta, which isn't going to solve nice. What do you think?
Could we do that using substitution?
You have an idea?
So you add 1 and then divide by 2 and then take the square root.
Add 1. 2 cosine squared equals 1, and then what?
Divide by 2.
Divide by 2. You guys feel like you feel it? Do you see we're getting there?
And then take the square root of 1.
Cosine squared equals 1/2. Now what?
Take the
Square root. Now what?
you have cosine equals 1 over square root 2 plus or minus.
Square root 1 over 2, and then I hear you broke that up into root 1 over root 2, which is really 1 over root 2. Oh my gosh, so much math. And then you even threw in something really smart, and then don't forget it. What did you say?
Plus or minus.
Plus or minus that, because this is an absolute value. And those of you that are thinking, I could have never done this. Yes, you could have. You'll just...
There's 4 answers, so.
I know. You're right. So now I got cosine x is equal to positive 1 over root 2. And cosine x equals negative 1 over root 2. And yes, there's 2 answers for this, and there's 2 answers for that. So there's 4 more answers. And you remember me saying at one point we'd have ones with 6 answers?
I don't think we should do those.
This is a one and done. Now you'll see something like this. But you're going to be a little smarter then. A couple days more of math, and then some review, and then... Okay. Let's just finish this off. The problem that would never end. Colin Colgan, the one on the left. Which quadrants should I either avoid or use? So A, S, T, or C? Good. And in these 2 quadrants, cosine is adjacent and hypotenuse 1 root 2. What's the other side? 1. So now it's a 1, 1 root 2. Do you know that angle, Mr. C? 45, which is the same as pi over 4. There it is. And then the other answer, if this was inverse trig, I would say the answer is about to be negative. Is this inverse trig? Nope, this wasn't even inverse trig. Got to remember that. That's part of the chapter too. But anyway, back to this. That's not negative. It's just a big positive answer. It's a whole bunch of pi over 4s. 7 pi over 4. 1 pi over 4 and 7 pi over 4. And then hint, remember that reinventing the wheel thing? You're not going to have to think about what these are. These are also pi over 4s. Okay, so then which quadrants though?
The opposite of
A, S, T, and C, which ones?
S and T.
S and T. So then in these two quadrants, given that they're pi over 4s, how many pi over 4s? 3 pi over 4 and 5 pi over 4. 3 pi over 4, 5 pi over 4, 1 pi over 4, and 7 pi over 4. But if set in the right order, 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that's just part of the answer, because over here, we had this one, which we didn't even do yet. The B team problem. Oh. Wait, you have to do both? Yes. No, you can't just find one of the answers. This is honors pre-calc. You got to find all the answers. Okay. Final answer on this one. Where is it? Sine is y, right? Which of these is the y-axis? Oh, that's the y-axis. Which one has a y value of 0? Well, if 0 would be like here, so I guess it's these guys. I got to double check them to make sure they make sense. This one's 0, and this one is pi. And are both of those spots where the y is 0? This is 1 comma 0, and this one was negative 1 comma 0. Yeah, they're both spots where y is 0, so they're both answers. 6 answers. Pi, 0, 1, 3, 5, and 7 pi over 4. That's a good question. We are sensitive to the fact that this test takes a long time. So this would be the kind of test where we're probably going to have only 8 questions, 4 easy ones, 4 hard ones, and only one will be a beast like that.
8 questions, but 48 answers.
There's a lot of easy ones, but there's got to be one like that. Come on, you gotta want the challenge. It's like if you're the best wrestler on the team, you want the other team's best wrestler. You want to be able to beat the best. You are some of the best, honestly. Okay. So, do you guys get? All right. So, I've given you help on the beast of the group. Okay, so you didn't have to do that one yourself, right? But there's only one last question even on this page. And a lot of people get confused by a cosine to the third. Like, well, what do I even do with that? Take a wild guess. Factor it. Thank you. Maybe will start coming to your mind quicker.
Not really.
For some reason, it's like a block a lot of you guys have. So yes, it ends up being factoring again. But I like the way somebody said it in here, like, should we do something to arrange it so we can factor it? Yeah. Because sometimes they don't just factor, like, if I just say factor that, it doesn't really work. You got to set it up right, and then you can factor it. All right. So, there are answers, of course, for all the ones that I did not do. I strongly recommend that you do the ones that I did not do, because that would be what's left of your homework. All right, so there's a few left that I didn't do at all, or that I partially started but didn't finish. So there, I hope you feel like you learned something, and that's all I have for you for today.